couple of videos because there's a fair bit of theory in this part, but looking a little bit closer at the unit circle here and trying to think about if we consider in degrees sort of the behavior of the unit circle. So just as a reminder, we're thinking of starting from sort of this point here when we measure our angles and considering that to be 0 degrees. And so we make our way anti-clockwise around the unit circle in degrees when we know at 1/4 of a circle is going to be 90 degrees, halfway around is 180, 3/4 of the way around is 270, and a full circle is going to be 360 degrees. And we know we're kind of moving in that anti-clockwise direction. So that's, I guess, a quick recap. But when we consider angles around the unit circle, and particularly thinking about angles that are bigger than 90 degrees, what we typically try to do is relate them back to the first quadrant. So if we've got an angle that's going to put us in the first quadrant, right? Well, that angle, if we consider that to just be called a general theta, then let's think about how that would relate to, say, an equivalent angle, but in the second quadrant. So in the second quadrant, we might have an angle like this that puts us somewhere in the second quadrant. And you can see from here, the way this angle is referred to is it's 180 degrees minus theta. So basically what we're talking about on this diagram is that if this first quadrant angle is equal to, if we're calling it theta, well, that's the same angle as what we're talking about over here. So there's a bit of symmetry involved, and hence the big title on this slide that says symmetry. Because basically you could sort of say that, well, if that angle there is theta, and so is this angle over here, then there's going to be some symmetry between this, make this a bit bigger, this point on the unit circle and that point there. They're basically going to have the same y value, and their x values won't be the same, but the one on the left will just be the negative version of the one on the right because of the symmetry of a circle. And if we keep moving down into the third quadrant, you can see that we're going to refer to this angle as 180 plus theta, so 180 degrees plus theta, and that angle on the diagram is just this one here. And when I go back to sort of labeling that point, again, you can see there's going to be some symmetry because we're just talking about this angle now being theta. So when you kind of relate this point back to the first quadrant, it's going to have, it's going to have the same x and y value as the first point, but just both negative, right? Because it's the same distance below the y-axis that this one was above the x-axis, above the y-axis. And it's also the same distance to the left of the origin as this one was to the right of the origin. So down here, we're just kind of flipping around and having a negative x value and a negative y value compared to what we started with. And in the fourth quadrant, we've got, we can refer to the angle as 360 minus theta. And again, this theta is just now, when we do 360, take away the angle, we're just talking about that there being our theta. So just to make up an example, say if theta was equal to, I don't know, let's just say theta was equal to 10 degrees, pick a really easy number. If that's 10 degrees in the first quadrant, then the second quadrant angle would be 180 take away 10, which is 170. Third quadrant angle would be 180 plus 10, which is 190. You get the idea. Fourth quadrant would be 360 take away 10, which would be 350 degrees. So that's just me plucking an angle out of the air as an example of what we're talking about here with the first quadrant, second quadrant, third quadrant, and fourth quadrant. And the idea would be that all of those 4 points, when we consider their coordinates on the unit circle, the first point will have a positive x and positive y value. All the other 3 points will have the same x and y values, just some of them will be negative because of the symmetry of the unit circle. So what that kind of means is that if we said, well, cos of theta, cos of any particular angle that's in the first quadrant, we know that that will be a positive number because all of them are positive in the first quadrant. In the second quadrant, though, which we could sort of say, well, cos of our second quadrant angle, cos of 180 minus theta, that will actually be equal to negative cos of theta. So it'll be the same value as what it was in the first quadrant. It'll just be negative. Likewise, in the third quadrant, so if we took cos of our third quadrant angle, cos of 180 plus theta, that will also be equal to negative cos theta, because we know that in the third quadrant, cosine is negative. And the reason that it's negative is because the cosine is coming from the x-axis. In the fourth quadrant, however, we know that cosine's positive, and it's written there on our little diagram here, because that was our all stations to Croydon. So cos of our fourth quadrant angle, cos of 360 minus theta, is actually equal to cos theta, but it stays positive, okay, because in the fourth quadrant cosine's positive. And you can kind of then just repeat the process for sine and for tan. So for sine theta, we know that if the angle's in the first quadrant, well, sine will be positive because sine, cos, and tan are all positive in the first quadrant. In the second quadrant, sine is also positive. So when we take sine of a second quadrant angle, sine of 180 minus theta, that will be equal to sine of theta. So it's stated as a positive value. But in the third and fourth quadrant, sine is negative. So sine of 180 plus theta is equal to negative sine theta. Okay, so we're in the third quadrant there. And sine of 360 minus theta equals negative sine of theta, because we're in the fourth quadrant, and in the fourth quadrant sine is also negative. So basically this idea of symmetry just means, well, if you can work out what quadrant you're in and what quadrant the sine, cos, and tan are positive or negative in, you'll be able to kind of relate everything back to the first quadrant value. So lastly with tan, super quickly, tan theta is a positive number. In the second quadrant, tan is negative. In the third quadrant, tan becomes positive again. So tan of 180 plus theta would just be equal to tan of theta. So basically, remember, all this is saying is that the third quadrant angle will be equal to, the third quadrant value will be equal to the first quadrant value. And when we get to the fourth quadrant, tan is negative again. So this is saying that the fourth quadrant value will be equal to the negative of the first quadrant value. Okay. I'll go through this one much quicker. This is the exact same thing, but just in radians. And really all I want you to pay attention to on this slide here is just how the quadrant values are labeled a little bit differently, right? So our first quadrant angle is still theta, okay? But remember that as we move around the unit circle in radians, we start from 0, but when we get to a quarter of a turn, that's pi on 2. Remember that 2 pi is a full revolution of the unit circle here. So a quarter of a revolution is pi on 2 radians. Half a circle is pi radians, because pi is equal to 180 degrees. 3/4 is 3 pi on 2, and a full circle is 2 pi. Okay, so when we label our quadrants, we can call the angle in the first quadrant is just theta. The angle in the second quadrant, though, we're going to refer to as pi minus theta. Instead of 180 take away theta, it's now pi take away theta. In the third quadrant, it'll be pi plus theta, instead of 180 plus theta. And in the fourth quadrant, if we're in radians, instead of doing 360 minus theta, you'll do 2 pi minus theta. But all the whole behavior of positives and negatives and stuff is exactly the same as in the previous slide. Okay, so that's all exactly the same. The only thing that's really changed is instead of using 180 and 360 to help refer to angles, we're now using pi and 2 pi. All right, let's have a look at some examples here. And you'll find, especially with these first few, that the process kind of, the theory, the learning is really, really complicated, but some of these questions will actually feel quite straightforward. So basically, this first, actually what I'll do is I'll pop the answers up and then I'll sort of explain them. That might be a better way to do it. So for the first question, this is saying if sine theta is equal to, 0.93, underlining in green there, find sine of 180 plus theta. So basically, we know that sine theta, or theta, I should say, is an angle that, like if we assume that theta is an angle in the first quadrant, then maybe, I don't know, sine theta might be something like that point there. Right, I need to make this pen a bit fatter. Right, so let's just say that's our, that's our point. So sine of 180 plus theta, well, that'll just be, like if theta was there, well then 180 plus theta will just kind of be like starting from 180 degrees and adding theta that way. So what we can kind of see is that sine of 180 plus theta will actually be in the third quadrant, right? And we know that in the third quadrant, sine is negative. So by symmetry, we know the value of this thing will be 0.93, but because it's in the third quadrant, it'll be negative. And so sine of 180 plus theta is equal to negative 0.93. Same value as sine theta, but it's just negative. And it's kind of just that simple. In these sorts of questions, all you have to do is work out what quadrant it's in, and therefore whether it should be positive or negative. So if you try this next one, or look at this next one, cos theta equals 0.44. So again, if we assume that theta is a first quadrant angle, maybe cos theta sits like, maybe theta sits sort of here on the unit circle. So when we go to do cos of 2 pi minus theta, that just means that instead of reading theta like that, 2 pi minus theta will put us down in the fourth quadrant. And we know that in the fourth quadrant, cosine's actually still positive, right? All stations to Croydon, or just think of it as we read cos from the x-axis, and in the fourth quadrant, the x values are positive. So what that means is that when we go to work out cos of 2 pi minus theta, it's actually the same value as cos of pi, but it stays positive because this is in the fourth quadrant. In the fourth quadrant, cosine is positive. That's kind of how it works. All right, so there's a couple more. These ones are in radians. You can see that we've got pi minus theta and pi minus theta. But other than that, the process is just, we can kind of interpret these questions the same way. So we can go, so tan of theta equals 0.93. And so maybe that's a value that's sitting like here on the unit circle. So tan of pi minus theta, we would read that as kind of going this way, right? So pi take away theta instead of just reading it as theta. But from the symmetry, we kind of know that the value of those 2 points, the x and y values will be the same. We just need to think, okay, it's the second quadrant and it's tan, so is it positive or negative? And in the second quadrant, only sine is positive, and that means that tan is negative. So tan of pi minus theta is equal to negative 0.93. Same value that we had originally, but negative. And that's, again, just because in the second quadrant, tan is negative. Okay, bit repetitive. Cos theta equals 0.83, so thinking of that as a first quadrant angle, so that's cos of theta, find cos of pi minus theta. So again, pi minus theta puts us in the second quadrant. We just need to consider in the second quadrant, is cosine negative or positive, and it is negative because only sine is positive in the second quadrant. So cos of pi minus theta equals negative 0.83. Same value that we had originally, but negative. And that's basically how those questions work. Okay, this one's a similar kind of question, but probably just worded in a more complicated way. So when you read it initially, it looks really confusing. But this is just saying, so if cos of x, so x is some angle that we don't know yet, is equal to negative cos of 60, and 180 degrees is less than x, which is less than 270, find the value of x. So basically, and again, what I might do is just pop the answer up and then talk you through it. This sort of restriction on x is actually designed to tell us that the angle, the value of x, is in the third quadrant because it's between 180 and 270 degrees. So basically we know, if we kind of recreate those little diagrams from the previous page, that might help. We know that we're looking at an angle down in the third quadrant. That's the value of x. And we also know that we can write third quadrant angles, or that we do write third quadrant angles as 180 plus theta. So basically, our job is just to work out what this theta is, and it's kind of given away in the question there. The angle that we're referring back to, or the value that we're referring back to, is cos of 60 degrees. So that must mean that the theta is actually 60 degrees. That's our first quadrant angle. So basically what we're saying is, over here we've got an angle of 60 degrees. Excuse that really bad diagram, what would be this equivalent angle down in the third quadrant? So that would just be 180 plus 60, because it's 180 plus theta, and so x would equal 240. And so basically what we're saying is that cos of 240 degrees is equal to negative cos of 60 degrees. And that's true just through symmetry, and through the fact that we know that in the third quadrant cosine is negative. Right.